our today's topic, Standardization Kit. And with this, a very warm welcome to our today's speaker. It's Jan Scherbel. Hi, Jan. Nice to have you.
Hi, and also welcome from my side. Thank you for having me. We'll have a look today at the Standardization Kit. And I'm glad to bring you this topic more in detail in the next minutes.
Yes, great, Jan. That's actually everything from my side. And if you're ready, we can start with your presentation.
That sounds great. Right. As said, also welcome from my side. Let's have a look at our standardization kit. First things first. What should you bring to have the best benefit from this webinar? Of course, basic knowledge about the TIA software and programming understanding, and also knowing the Simatic portfolio and its very basic needs. And you'll get the best overview to understand the basics concept of standardization, what the thoughts are, and what Siemens offers to you to fulfill the requirements of standardization. And we'll also have a look on how to program in a modular way. At first we'll have a general look, then we jump to the guidelines, looking at libraries, the machine template, and closing the session with the software units. First things first, standardization is a very important topic, as you may already know. We have a lot of challenges in today's world, and we have a very high demand of custom and very complex solutions, which have also to be adapted. We have changing product, changing requirements, and frequent updates. So we have to adapt fast and meet the requirements. Also, while we have a very high rise in security requirements and security risks, so we have also to look at the security mechanisms and match these requirements. And as always, competition does not sleep. We have an increase in the global competitions. Competitors always look for the next thing. That's not easy to match always, because we also have the challenge to find the right talents, the right experts, which have the best knowledge in these topics. A lot of challenges, and they can be met well with the standardization. Why? Because with standardization, you can shorten down your time to the market. You have more predictable times for the projects, and you get a higher degree of modularization. You can reuse a lot of software and other equipments more and more, and that's a very big thing to match these requirements. Also, with standardization, with a very good concept, the benefit is that we have less unplanned services, and when we have maintenance can be done in a quicker way. When we have a standardized, for example, diagnostic concept, we'll come to that later on. We will find faulties and errors a lot quicker, and we can fix them a lot faster. Of course, standardization is a very broad topic. It's a very wide topic, and that's the reason we have to focus today. Of course, there are a lot of different fields where standardization plays a significant role. For example, on the mechanical side, on the IT level, we have, of course, documentation, electronic plannings for the plants, and also on the PLC and HMI side. And for today, we have a look especially at the PLC and HMI level. And let's have a look what it means. First things first, when it comes to standardization, of course, general guideline and guidance is a very important thing, and it's the starting point on the general understanding. And we'll have a look at the guidelines we provide and also how to check them. For the first thing, regarding the PLC level, of course, we have the guideline for the S7 1200 and 1500 programming, where you get a general idea of what are the basic programming guidelines, how to program independent from the hardware, and basics about safety in the TA portal, and the automated generation of visualization, of course, plays a role. And you will also always see most important recommendations when it comes to the programming of the PLCs. What is important and why is it very helpful for you? Of course, this eases up the maintenance effort and increases the reusability of software components in the programming side, and also you get a faster and more easy error recognition, and you can correct your faults much quicker. And also, this is the basis of an efficient cooperation of multiple programmers. As said, we have a very complex world in here, and a lot of programmers which are involved maybe in a project, and this acts as a common basis. So, as mentioned, we'll have a look at the guideline. Of course, when you're interested, you will find it in the C portal, of course. And it's of course a very broad field. This document is also very wide in the range. Of course, we have the first content in here, which are the general innovations. But let's have a look at the general programming section at first. So what is the content in here? Of course, always we have the most important things about the specific topic summed up, like in the programming and the TA portal for the S7 1500 software. They have the basics of the software design with the OBs and the function blocks and the functions. And when you scroll down, you'll always see, okay, what are the recommendations is important to consider in the programming. Of course, the structuring and so on and so forth, which programming languages are supported, for example, and much more. As you see, this is a very broad document, a lot of information in here. Of course, it would extend the webinar time a lot if we go through it in detail. What is important to know? The document provides a general understanding and general recommendations also on how to program in a modular way. We'll have a look at that later. We'll also have a look at the examples we provide with it. Next thing, of course, on the PLC level, we have this guideline, but also the visualization plays a big role in here. And for that, we have an HMI guide, which is mostly about globalization, how to do your nomenclature and the formatting. And as of course, not only on the PLC level, also on the HMI level, it's very important to think about reusability, how to design your software and stay with a high performance. That's the most important here. As it's on the PLC level, it's the same on the HMI level. It's mostly about also easy maintenance, how to increase your usability so you don't have to start from scratch, and also how to act fast in case of any errors or faulties. In general, we'll have a look at this later on. We should think about, okay, a general understanding, a general design on the HMI side, so it's easy for the operators to act with the machine, to operate it, and of course, a general and unified operation design helps a lot here. The third guideline we have is the safety guideline. It helps you when it comes to the configuration, how to program with safety, how to optimize safety. And the benefit, of course, is again the reusability. So program parts and components can be used again, and it also helps you for the easy acceptance. Increased flexibility, of course, is a very important thing here, because when you have your already defined components, you should think about, okay, how can you configure it to adapt most cases, and don't be very specific to each case. Still, it has to be adapted and be very flexible. Of course, when you utilize the guidelines, you will also have a reduced runtime. So program code is optimized in this way again. This means we have a lot of rule sets. These rule sets are, of course, time intensive to check. When you have your project in the TIA portal and you want to verify against the guidelines and the rules. And this is the reason the so-called project check in the TIA portal comes in handy. The project check, as it's in the name, checks for the rules, and you can get an export of the evaluation. And this is the best benefit. It saves a lot of time, and also checks on the one hand side on the programming style, but also how the program is done, on the technique in general, and of course how the test cases from a technical specification are done in the user perspective. All right, so let's have a look. How does it look like in the real world? I have prepared a little TIA project here, and that's the reason we want to check it. So we'll look for the project check. So we open the software. In the software we see the currently opened TIA portal projects, and then we can connect to it. And here we can select, okay, what parts of the program have to be checked on. We see our PLCs and also the library types or the master copies. Due to time purposes and time reasons, we'll select the first PLC. And on the next window, we see the rules we have implemented in the project check. Of course, the usual programming style guide for version 7, 1200 and 1500 is automatically inside of the project check, but you can also add your own rules and rule sets defined in the TIA portal. And here we have different contents and the different rule types. For example, when it comes to the design of the architecture, we have checks for the programming language. Of course, there are recommendations on what can be programmed in what programming language. For example, when we have very detailed block, the technical and dev. On the control side, for example, when we have a drive function block, it makes sense to program it, for example, in the SEL programming language. This is a thing we take into account in this rule. And programming content or programming blocks which gather or collect content. Maybe we have to define a module with 4 drives. This is mostly recommended to program in a graphical language. Yes, also we recommend to use the PLC data types, so we avoid structs and other customs large solutions, because when you use the data types, your program gets shrunk down and it is more performant. Yes, this is just an example. We have a lot of more rules, of course. We can check on the reusability, of course. We talked about this before. The reusability is, of course, very handy because when you define a program module, for example, you don't have to program it every time. You can reuse it, of course. You should take into account some rules when it comes to the reusability. So, of course, the versioning, we talk about this topic later on, of the different contents should be done in the libraries. So we also provide a versioning which comes in the library solution. And that's, of course, very important to have. And also, symbolic programming is an important role to make the program code on the one hand side reusable, but also maintain a very high readability. Okay, so we have seen some examples. I'll just select a small rule. So we have a quick evaluation of our program, and you can see how it is done in general. So for example, and that's also, of course, benefit we have in here. We can apply the rules, we can deselect the rules as we need it for the current project. And let's see, okay, maybe we select some two rules and we hit on the check. And then the evaluation is started. On the technical side, it's done with the TIA portal openness. And let's see if TIA needs something, but it looks fine. Then on the parts we selected before, in this example, the PLC is evaluated with these two rules, and we'll soon have an end result on the evaluation. And you can see, okay, we have different types of it, some information, some warnings, and some of the errors. Of course, since this is a template, it's not not applicable to fulfill all the rules because it's a general solution and not fully programmed in a specific way. Yeah, but you can filter it and see, okay, what are the warnings? What does it say? You can already see, okay, where is it located? Where do we find the parts? What is the object? So is it a function block? What is it called? And so on and so forth. So you can also export the result. And for example, when you're in the project, you check for the rules. You can export it and send it to the programmers and so on and so forth. So this is the way to check on a very broad range of rules and rule sets from the guideline without the need to click on it on a manual way. So this saves a lot of time and is of course very handy when it comes to the check of application or the existence and fulfillment of our rule sets. Yes, this is some example. Of course, in the TIA portal, you can, in general, you can define your own rules. And this, like we said, we have different topics or different categories for the rules. On the one hand side, on the settings in the TIA portal, reusability plays a big role. And of course, may you ask, okay, why should be there a general rule set for the settings in the TIA portal? Of course, when you're working on a big project and maybe you have only some of engineering stations and multiple people work on the engineering station, you can define how it should look like. So every programmer or every one who works with the engineering station can get to work very fast. It doesn't set something up or change on this personal belongings. So this is a general understanding on how the TIA portal settings should look like. And of course, the reusability, we talked about this earlier. We have to or the library versioning makes sense. We'll have a look at this also in the next minutes, and much more rules to apply. Okay, library handling in general in the TI portal is a very important part and the key point, and also standardization, modularization. So for that, because we have a central update functions of all the instances in the project. So since the library concept is based on a type instance concept, so we program the type, we maintain the type, we fix maybe some errors or falsies in the type, and we can instantiate it multiple times. And for example, when a new version of a library comes out, we can roll it out by one click. Also, we can centrally display what instances are used and what types are used. And also we have system-supported version management of the library elements. Also, we can track library elements. We can track the changes like that with a versioning on it, and we can ensure consistent use in the project. We'll have a look at this in a minute. Also, when elements are defined as types, we have them highlighted in the project, and we can compare it. This provides, of course, the opportunity for your project or for the company to create a corporate library to roll it out, but also set a library for a group of applications, and also utilize the libraries we provide as Siemens. All right, so let's have a look on the libraries in the TI portal. As said, I opened up here our example project. You find this project. I'll mention it also later more in detail in the C portal. So this is called the machine template for a 1200 and the unified. And in the TI portal, you find, of course, your libraries. And in this example, the libraries of the project are shown here. And you see also on the right-hand side the status. Are they consistent with the current project? Maybe we have to update it. Maybe we have to change something. And in this example, we can have a look, for example, at the LPML library, which is the PackML library. And we see the content. We have our, for example, our UDTs in here and a function block, which is called the unit mode state manager. On the right-hand side, you see the current current status of the version, and in case something would change or some increments in the version are done, we see it listed in here. Also, when you have a look at the LOC, we'll talk about this in the next minutes. This is a very good example. For example, for the status collection, we have updated the version, and we see that it's consistent with this using the project is using the default version of it. Yes. In case of an update, it's very easy to implement. You can use the context menu in here and say, for example, update types in the project, and so on and so forth. Okay. Yeah, this is just a general introduction. We'll talk about the libraries in the next minutes. So this is the first part. And thanks for listening. In case some questions arose, I'm happy to answer it now.
Yes, just let me check. And there is a question that just popped up. The question is there a function to automatically synchronize between project and global libraries?
Okay, maybe we can specify this this topic a little more. This question, yes. My question would be how to synchronize. Of course, you can bring your global libraries in the global library section in here, and with V18, it's also supported to manage your libraries in the project server. And for example, when we open it up, we can right-click and update the project library from the global library with one click. So that's possible to synchronize with the context menu. Yes.
Hey, thank you very much, Jan. And just let me check. Okay, that's a more general question or a very specific question. I think we can have a look at that at the end at our Q&A session.
Okay. Yeah. No worries. We'll have a look also on the libraries, the next topic, especially for the library of basic controls. So what is the library of basic controls? The library of basic controls provides 10 function blocks, which can be then used as a control module. If you're not familiar with the word control module, we'll talk about this in the section of modular programming. And we have a detailed user documentation about the function blocks and the concept ideas of the LBC. Yeah, what is the benefit of the usage of the LBC, or maybe also in general for the libraries? Of course, you reduce the risk and integration effort. So what does it mean? Maybe you get a library already developed from Siemens, it's already tested, it's already verified, it's well working, it's also using existing standard, for example, the Siemens internal guidelines or the PLC open standard, and you don't have to program it by yourself and verify it by yourself. And this is also possible to provide future-proof technology, because this library is still is currently maintained and also further developed and extended. What are the key features of it? Of course, you can use it either in a standalone or standalone function blocks, or you can integrate them in your higher level program hierarchy. So maybe into modules and other stuff. So this is, of course, the part of modularization, and you can use them as you need them in your project. I talked about this in the beginning in a short sentence, that of course configuration is so you can either embed this in the higher level components and then use it either directly in maybe some global data blocks, or then reference from the higher level module to this configuration parameters in a global data block. Of course, the LBC is a general approach, so it's a fundamental technical function. So you can use it independent of your field of application. So when we jump back for a moment, for this example, I like to use the two-way actuator here. So the two-way actuator is a very general function. Maybe it can be a valve, or it can be a cylinder, so a push application that's defined by yourself. You can configure it in a configuration block and use it as you require it. So that's a very general approach to it. What is important to know? Of course, this can be a starting point of your individual path on standardization. And it's easy to approach and have a look at it, because it's free to use. You can download it in the C portal, and it's also continuously extended and improved. And with versioning, you can always roll out the latest changes to the project. As said, we follow our own guidelines and the Siemens programming style guide, but we also use the PLC open standard, so they are used both. Yeah, of course, this is not the only library we provide. I got some examples for you today. Of course, there are much more libraries than only these. But I think this is a very nice selection and example of the libraries we have. The LGF, this is called the Library of General Functions, comes with, of course, basic functions on, let's see, the function-orientated purpose. For example, when it comes to data handling, mathematical operations, timers, or counting applications. So that's of course the best library for here. When you may be a little advanced in your standardization journey, or you already use the modular type packages, the control function library comes in handy here, because this supports the usage of the MTP, the modular type packages. We saw that earlier also in the project. We have a library which is called the LOC, the Library of Unit Control, and we support this library with the machine template. So it's implemented currently in the machine template. It follows the PACML standard and the OMAC model. So this can be utilized also for the unit control. When it comes to data streams, the LStream library is also a very good fit. And of course, all these libraries are available and requestable through either through the C portal or through the Siemens partners. So you can contact your Siemens person in case of questions about it. Maybe you want to order it. Okay, that's the general understanding of the libraries. Let's have a look at this in the TA portal for a second. With this example set, we have the library of unit control, and in here we have a general function. Of course, what is usable on the unit level, maybe you need a status collection for your modules, you need an interface management, maybe you have some commands or information coming through different sources. You have your you have your connection with the OPC and an example for the signal stack. So that's a thing we'll have a look also in the next minutes. We'll have a look more into the machine templates. Okay, if you want to jump directly into it, I provided you all the links about the topics we spoke about earlier. And again, we have now the possibility to answer your questions.
Yes. We have a question about style guide in TAA, standard namings. Is it something we should talk about right now or more for the Q&A at the end?
I think this is applicable for the Q&A because it sounds more specific.
All right, and the next question is also very specific. I think we also have a look at the Q&A.
Okay, sounds good. Next up, as said, we have a look at the machine template. Of course, this is an example on how to do modular programming. In general, modular programming, or in general, why is it handy or why is it necessary to have a general understanding on the programming and the design of the machines? Of course, there's no specification, then there's no definition. Every manufacturer, every OEM does what he is used to do and defines it by himself. So maybe he utilizes a different protocol, maybe he utilizes different connection technology, and he uses its own interface. So for the same machine in this example, we have 4 different concepts. The first one, maybe the temperature is set in degree Celsius. The next one is in degree Fahrenheit, or we have Kelvin. So different concepts, and without the standardization concepts, we have a very high integration effort. We have to clarify, okay, what does every point in the interface mean? We have to think about combining all these different connection technologies, and that's a very big effort. When we jump to a general understanding and a general definition on how machines have to be designed, the connectivity is very easy to do. For example, when we agreed on the same connection technology, maybe we all use the OPC connectivity, and we all use the same interface, so it's all in degrees Celsius, and also the total count is always in pieces per hours and not pieces per minutes or something like that. The connectivity and the integration effort is very well optimized. Of course, when it comes to such specifications, you do not have to start from scratch. At Siemens, we provide the so-called technical specification. We'll have a look in the next second. And we provide this to the end customers and also to the OEMs. So when we talk with our customers, we specify, okay, what of parts of the specification are required. Maybe there are already existing specifications, and then we can adapt it. Maybe we have a different, there's an understanding also in existing parts, and then we can roll out the specification to the different OEMs, and each OEM benefits from this existing specification and knows how to do what. And of course, we is fulfilled. Let's have a look at it. So when we see at the bookmark section, we can see that a very broad field is specified in this document. On the first thing, of course, we have a quick introduction. I made this first to you when I told you about it, but of course, for readability and the general purpose, it is a quick introduction to it. Also, we have a definition on what deliverables are to be expected. So, what is important, what are the trainings and the maintenance the machines regarding, and much more. Of course, besides from the general requirements, we have specifications about the hardware. So, as we focus on the PLC and HMI level for today, for example, we have the definitions for the PLC platform guidelines, for example, that the real-time communication should be done via the Profinet, and the safety should be done with the ProfiSafe. And we have a little overview on what to use, what types with fail-safe technology, maybe high availability, or the open controls on the PC level. And we have already provided a list on what is the most preferred way, what is maybe compromise, what is the mid-level way, and what is not preferred, what is not recommended. And this on the PLC level, of course, is a guide on how to find your PLCs, find the right PLCs, what should be taken into account. For example, what is the load of the PLC, so it shouldn't be higher than 70%. And also we should have enough working memory, so we can ensure well run of the PLC. When it comes to the HMI side, of course, we have the different solutions on the HMI guidelines. We have on the one hand side the panel-based HMI platforms, which is always a recommended way, what can be used. So we can see, okay, we recommend here the unified comfort panels, and we can also have an alternative with the comfort panels. And this is the general idea of the technical specification, to get a very general and unified concept on the machine design and how to look at it. Of course, since this is a very broad field, we have recommendations about the network technology. For example, I told you about it earlier. We have a Profinet communication, and when it comes to non-real-time communication, the OPCOA or 7 communication protocol is advised here. Since the OPCOA is a very well very well-known standard on the communication side. This is very handy. Comes very handy. Yes. Okay. Yeah, we have, of course, recommendations, of course, about security, how to do the engineering, ensure machine transparency, simulation, and much more topics. If you're interested in this technical specification, you contact your sales person, and he can create a service request and will provide the technical specification for it. Yes, this is the theoretical part, let's say, and on the part of the TA project on how the machine can be designed, we also saw this earlier, is the machine template. So with a machine template, we can support the OEMs to ensure that everything is successfully implemented. On the one hand side, we have fulfilled the integration requirements. We communicate with the higher level with OPCUL, for example, and it follows the state machine or the state concept from the OMAC model. And we also have an example for stack line. Yeah, also we follow a holistic architecture. So you'll see solutions not only regarding the core of the PLC, the step 7 programming, we also have a solution on the communication and the connection to the HMI, to the periphery, and also about the safety, and to the higher levels in the IT. And this acts as a common basis also for other Siemens solutions, maybe some application examples in the future, and also the libraries and so on and so forth. One thing I have to mention here, this machine template is also developed and maintained, so you can expect to be it to be up to date. As said, we have the integration to the IT level, and in here we have the example with the OPCUA utilizing the basic information model. So this is, like said before, a general interface about the machine information, machine status. So the equipment ID is always in the same type. It's always the same name, for example, also the equipment name, line ID, and so on and so forth. Also about the structure of the status. So this is defined in a unified way. About the architecture, of course, as we see, we have the integration into the libraries. It is possible to use it with add-ins, and we ourselves, and also you can use the multi-user and use every new technology. Yeah, modular programming also follows the modular structure of the ISA 88 approach. So we cut down the machine into different modules. So the machine level is, of course, the next level, the equipment module, and on the lowest level, we have the control modules. So for example, maybe the control module is some light beam or some drive, and in the equipment module, maybe you have some pick and place application. Maybe you have a tray handler, or maybe you have a conveyor station, and this could be equipment module. And of course, the different equipment modules build up the machine. This comes with 2 versions. We'll have a look at the software versions in the next minutes, and also we provide the classic PLC structure as well. All right. Yeah, this is the already known TA portal project we have in here. It is the machine template, as said earlier. And when we have a look at the program code, we see, okay, we have our unit here, different equipments. Of course, this is an example, which is this is a template. In reality, maybe your unit has a specific name, like let's say maybe you know the Digi demo machine we shown first. maybe the unit level is called the Digi demo, and then we have the different equipments, maybe some conveyor station. This could be a conveyor station, and on the equipment level, it is done with a sequence, and we can see, okay, on this level we have the state actions, what should be done and when, and also inside of the equipment we have the control modules. In the example of a conveyor station, maybe you have some light beams, maybe you have some drives, and this can be implemented also in here. When it comes to the unit level, of course, we have the unit information and the unit logic in the unit call environment. So every call environment is fitting to its logics and to the information. So on the unit level, we have this collection of the different status of the equipment modules. You can see, okay, we have an interface manager, maybe we have some information coming from outside, and also we handle a machine mode. Of course, this utilizes the XML standard from the OMAC, so on and so forth. We have implemented the signal stack connection with the OPC UA, and this is the unit level. When it comes to maybe some very motion-specific information, this is also implemented in the equipment C, which is about the sync cycle. So this shows, okay, how can some time-critical applications be implemented as well. This is a very specific approach, so I don't jump into detail for now. If you're interested, have a look at the SIAS, and you can always contact us, of course. Okay, for further information, of course, as said, we provided in the C portal, or the so-called SIAS. You can download it free. Yes, well-known slide. Of course, this is we concluded our next topic. So in case you have questions, let's see and have a look at the questions.
Yes. Thank you, Jan. We have two bigger questions for a Q&A at the end, and there's a shorter question. The question is if calculation sheets are available on SIAS to check the choice of the correct PLC when, for example, you have to work with 4 technology objects access with 5,000 tags per second, read over OPC UA, etc. Can I put this data in some table to select the CPU with the correct performance?
Well, that's a very good hint. For now, it's not part of the machine template. This would be, I see it more on the side of the technical specification. On technical specification, it's a very, as we saw, generalized approach. And this would be, in my opinion, a thing we would have to specify individually, because it is, of course, an individual approach on what are the runtimes requirements and so on and so forth. Okay, but this would be, of course, on the technical specification. If you want to know more about it, I can welcome you to contact your salesperson, and then he can arise or create a service request for it. That's the current information. I write it down. If it is technically feasible and possible, we'll provide this in the future. That's a very good feedback. Thank you for the feedback.
Okay, thank you, Jan. So far, no more further questions.
Okay, so let's jump to our last part of it. This is about the software units. In general, software units provide for you the possibility to divide up PLC content into individual parts. You can sort them either on the technological approach or on the collective approach, about like said earlier, about the different modules. And they can also exist parallel to the, let's say, classic program structure. Yeah, and each software unit is self-sufficient, so it can compile it on its own and can be downloaded on its own. And data exchange between the software units is done by relations, and the related data has then to be published. For example, the usage of a library. As said, each software unit can be compiled and downloaded by its own. And this ensures an independent and modular approach for development, testing, and also the commissioning of a machine. And it also improves the programming structure because data is then published or non-published. Maybe when coming from the object-oriented programming, this would be somewhat private and public information. And this reduces also the engineering effort because it's very well to understand and it's very well structured. As said, the compile and the download can be done per unit, and of course this improves the general performance during the commissioning. Compile and download have to be only done or mostly done on the unit level. Of course, performance can be increased because maybe you're somewhat forced to do only symbolic and addressing and only using the optimized data. So of course this ensures the best performance. So let's see on the example in here. In the machine tab, as said, we have one solution on the classic approach and the other solution of the software unit approach. And the next thing we have also in the software unit side is this topic namespaces. Let's have a look at it in detail. Yes, when we jump to the solution with the soft units, of course, we have to navigate not to the program blocks, we have to navigate to the soft units, and we see every part of the machine is divided up into one unit. On the one hand side with the libraries, on the other hand side with the global data, with a safety software unit, and then we have the unit for the machine level, the unit level, let's say, and then also the equipment module units. Let's see. Also, each unit has its own namespace. Yeah, this is equivalent to the name the software unit. Of course, this can be done in a different way, and this is the concept we follow this example. As you see now, in the unit level, we only have the call environment for the unit, and due to the namespace, it's now only called call environment because it's following the namespace and somewhat private to its own software unit. Inside, of course, it's the same, built up in the same way like in the classic approach. So you can see your logic in here, the interface management, and so on and so forth. And when we jump on the equipment module layer, we see, okay, the equipment module layer has its own main OB. This is possible due to the namespaces. Yes, and this follows also the same approach. We have our call environment, which calls all the content on the equipment. And then we see, okay, we have again the production states, maybe we have some simulation. And there we see, okay, that for example, we have a control module, and this control module comes from a library. And this example, this comes then from the software unit libraries and follows the namespace libraries. We see it here. And of course, when we have a look at this example for the demo of the control module, we see, okay, the demo of the control module is related to the software unit and it's published. And this shows this little green dot. And when we check on the relation, we see, okay, nothing from the library is related, but when we jump to the relations of the equipment, we see, okay, this is related to the libraries and also, of course, to the global data. So relations is done one way. Adern only. Yes, and as you can see, every unit has its own structure. It can have its own data types, its own tags, and so on and so forth. So it's like a little PLC program in a PLC program structure. So that's the neat way of the soft unit approach. For further information, you can have a look at the Simatic software units for the engineering and commissioning. And also we have tips and tricks on how to work with the soft unit approach.